Hello everyone, Nathan with Honeycomb here, and today I'm going to show you an example of using Honeycomb to solve problems that your users run into. So what we're going to be doing is we're going to be walking through what you can also do at home in the Honeycomb Quick Start. So if you would like to actually try this out for yourself later on, I highly recommend that you sign up for an account and go through the Quick Start tutorial. So the setup for this scenario is that users have been saying that our website is slow. And what we're going to do here is we're going to take a look at the events that we're sending to Honeycomb, of which you can see some examples here. They have properties like round trip duration in milliseconds, which would be the total amount of time that we took to serve an HTTP request. And we're going to use Honeycomb to actually visualize what's going on in our system so that we can solve this problem. So the first thing that we're going to do is we're going to click the calculate box here. We're going to look at the average of round trip duration over time. So first we need to confirm that our users are actually experiencing a problem that's measurable on our end, and it does look like it's true. The problem is with our application because we can see that the average round trip duration in milliseconds keeps going up and up. So normally we would be suspicious of something like a recent deploy, but it turns out that we actually annotate all of our deploys in Honeycomb using markers. So this vertical line here represents the most recent deploy that happened, and there are no other vertical markers on the graph, for instance right here where the problem started happening. So we can rule out a recent change in the code or a deploy as a suspect. Instead, let's take a look at some related fields. So inside of the fraud duration milliseconds field, we actually are tracking how long we're spending on calling out to a third-party service. So we should be able to see if this third-party service is what's making our code slow or not. Here it actually seems that the average of time spent on calling the fraud duration service is consistent at around 20 or 30 milliseconds and does not seem related to our problem with general request latency. So let's just go ahead and get rid of that. Now, as always, a perennial suspect is the database. So we actually measure and include in these events that we're sending information about the amount of time that we spend calling MySQL. So let's graph that alongside the round trip duration milliseconds. So you can see here that the round trip duration milliseconds graph and the MySQL duration milliseconds graph are very, very, very strongly correlated. The problem with the requests in general seems almost directly related to this problem with MySQL duration latency. So it definitely seems like the database is a source of our woes, but we're not really sure what exactly could be going wrong. So wouldn't it be nice if we could actually visualize somehow which of the endpoints in our application are going the slowest, right? So you might recall, we can see this if we click on data mode over here, that each of these events that we send has an endpoint as well as an endpoint shape field, where endpoint represents the literal endpoint that was called, and endpoint shape represents sort of a template with parameters that might get turned into variables inside of our HTTP handlers. So luckily, we actually can use the Honeycomb breakdown to group everything by endpoint and visualize in many, many distinct colored lines on the graph the many different latency patterns of the different endpoints. We can also order by average round trip duration descending so that we can actually, in our tabular view down below, get a view of which are the slowest endpoints. So you can see right here, average round trip duration milliseconds is going down for the various endpoints. And what do we have on the top? Well, it seems very clear that if we hover over these endpoints, one thing that they all seem to have in common is that they all have this colon product name here. And you can see on the graph above that these lines boop, 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 are all the most latent lines, and the rest of them seem to carry on without an issue. So our problem seems directly related to latency of the database and a product name field. So as you can see here, Honeycomb has allowed us to very, very quickly dig deep into an issue that our users are seeing, which is application slowness. And this is just the tip of the iceberg, folks. Honeycomb has all sorts of transformative, powerful potential for observability in your organization. I hope you enjoyed this video today, and please reach out if you have any questions. Thank you.